Hi and good morning, everyone. Today's class is about problems on rolling motion, as you can see. Let's take a short recap of what we have done so far. In this chapter on rotational motion, we started with moment of inertia. Some of you people have asked me questions on moment of inertia, and I'm really happy that you're watching the videos again and you're going through all of it really carefully. Thanks a lot. I'm really proud of you. And after moment of inertia, we did a few theorems: parallel axis theorem, perpendicular axis theorem. And then I told you that there is a concept called as torque. Okay, so you try to apply a force on something, the thing is going to move. But if you apply the force at a different point, or you apply the force in such a way that the thing starts rotating, the effect of that force is called as torque. So using torque, we can find out angular acceleration of something. We initially started with some very simple problems, then we went on for more complicated problems. Okay, slightly harder problems where there are two objects, or where there are three objects, there are two blocks and a pulley. So there'll also be problems where there are four, five different objects where you have to calculate different things like tension, you have to calculate acceleration, all of that. All of these things, they come into what's called as rotational dynamics. And normally in a class, they are taught as part one of rotational dynamics. Rotational dynamics is a pretty big chapter. It's pretty important, especially from the advanced point of view. Problems in this chapter, they even come in NSCP, they come in IPHO, right? So you have this chapter is pretty important that way. So we split the chapter into two parts. As of now, like some of you asked, part one of this chapter is over. So this is part two of that chapter, where we are going to start with other things like angular momentum. We are going to start with rotational collisions. We're going to start with problems where there is more than one concept involved. So we are basically almost winding up with the concepts. As far as the concepts are concerned, you just need to know about what's called as angular momentum. And that will be done in rotational motion part two around the first lecture. So this is still part one running. We are doing problems on rolling motion. So that's just to give you a roadmap of where we are. Let's start today's class. I'll give you some problems that we already did in the last class, but okay, try them once again. Let us say that there is a plank, and on this plank, there is a wheel. There is a wheel that's kept on this plank, and the plank is moving with a speed of 5 meters per second. The plank is moving with a speed of 5 meters per second, and the wheel is rotating on this plank at a speed of 1 radian per second. So omega is 1 radian per second. Omega is 1 radian per second. So there are 3 points on this wheel. There's the top point of the wheel. You know this thing, right? TCS or TCB, bottom. So top, center, and bottom. There are 3 points on the wheel. That is the way I call it. You can call it A, B, C. It's up to you. So there are 3 points on the wheel. All you have to do is find out the velocity of each of these points. What is the velocity of the top? What is the velocity of the center? And what is the velocity of the bottom of the wheel? If it is known that the wheel is rolling, कर पाओगे? क्या करना है rolling motion में? The bottom part of the wheel is in contact with the plank. So because the wheel is rolling, the velocity of the bottom part of the wheel and the velocity of the plank should be the same. So the velocity of the body should be equal to the velocity of the surface. ठीक है, वीडियो पॉज कर लो, खुद से ट्राई करो. Velocity of the body is equal to velocity of the surface at the point of contact. At the point of contact. तो पॉइंट ऑफ कांटेक्ट में जो नीचे वाला पॉइंट है, एज यूजुअल अपन वही चीज करेंगे. लेट अस से दैट द वेलोसिटी ऑफ द सेंटर इज इक्वल टू v. So the velocity of the top is also v, so the velocity of the bottom is also v. Now because the wheel is rotating, क्योंकि तुम्हारा wheel rotate कर रहा है, so you can say कि the wheel also has an additional angular velocity to it. तो ये कितना हो जाएगा? ये हो जाएगा r omega ऊपर. Some Dutch problems here. The center part of the wheel is not going to move at all. And the bottom of the wheel is going to move backwards with a speed of r omega. तो ऊपर वाला पार्ट क्या कर रहा है? आगे जा रहा है r omega. नीचे वाला पार्ट पीछे जा रहा है r omega, और बीच वाला पार्ट zero as usual. So what is the velocity of the top part? The velocity of the top part is equal to v. There are some touch problems today. Bear with me. One second. So I fixed the audio problem and now the touch problem is bothering me. Okay, so Vt is equal to V plus R omega. Now the velocity of the center of the wheel is just purely because of translation. So it's just equal to V. and the velocity of the bottom of the wheel is equal to v minus r omega. Velocity of the bottom जो है v bottom is equal to v minus r omega. तो ये wheel का top part है, middle part है, bottom part है, three parts of the wheel. Now the velocity of the bottom part has to be equal to the velocity of the surface. So the velocity of the surface is equal to 5 meters per second. So velocity of the bottom is equal to velocity of the surface. You can call it S. That's why I called the bottom as B. So velocity of the bottom, V minus R omega, is equal to velocity of the surface, which is equal to 5 meters per second. I just realized I did not give you the radius of this thing. So let us say the radius of this thing is equal to 1 meter. For those of you who paused the video, you should have gotten an answer in terms of R. Okay, just because I didn't give you R, you should have gotten an answer in terms of R. तो v का वैल्यू कितना होगा? v will be equal to 5 plus r omega. तो r omega कितना है? r is equal to 1, omega is equal to also 1, so v is equal to 6. मतलब सेंटर पॉइंट का जो वेलोसिटी है दैट इज 6 मीटर्स पर सेकेंड. तो व्हील कितने आगे जा रहा है, कितने स्पीड से आगे जा रहा है? 6 मीटर्स पर सेकेंड. आई विल आल्सो एक्सप्लेन दिस टू यू इन अ स्लाइटली लाइक मोर नॉर्मल काइंड ऑफ अ वे, लेमैन काइंड ऑफ वे, लेकिन पहले इसको सॉल्व करते हैं. What is the velocity of the top part? The velocity of the top part is equal to v plus r omega. That is equal to 6 plus 1 times 1, 7 meters per second. ठीक है, ये तुम्हारा टॉप पार्ट का वेलोसिटी है. What is the velocity of the bottom part? वो तो ऑलरेडी अपन निकाल चुके हैं, 5 meters per second. ठीक है, प्रॉब्लम समझ में आया? हाउ डिड वी सॉल्व इट? 5, 6, 7 जैसे भी आ रहा है. Now think of it this way. अगर तुम्हारा व्हील रोटेट ही नहीं करता, इफ द व्हील वाज नॉट रोटेटिंग, व्हाट वुड हैपन? द व्हील वुड जस्ट मूव एट 5 मीटर्स पर सेकंड, क्योंकि प्लैंक भी आगे जा रहा है 5 मीटर्स पर सेकंड से. द व्हील वुड आल्सो गो फॉरवर्ड एट 5 मीटर्स पर सेकंड, देयर वुड बी नो चेंज. अब मान लो प्लैंक मूव नहीं कर रहा है, ओनली द व्हील इज रोटेटिंग. So in such a case, the wheel would move forward at 1 meters per second because of the rotation. जो wheel rotate कर रहा है, तो r into omega कर रहे हो तुम, तो 1 times 1 इसका कितना आ रहा है? 1 meters per second. ठीक है, तो जब दोनों कर रहा है, the wheel is also rotating, the plank is also moving, तो इफेक्ट क्या होगा? इन दोनों का इफेक्ट ऐड हो जाएगा and you will get 6 meters per second. तो एक बार तुम्हें ये 6 meters per second समझ में आ गया, तो उसके ऊपर और एक और बार ऐड करोगे, उसके नीचे एक बार सब्ट्रैक्ट करोगे, so this will be 5 and that will be 7. Okay, so this is a pretty layman way of explaining it to someone कि क्यों जा रहा है 6 पे. It's because the plank is moving, the wheel is also rotating, तो दोनों का इफेक्ट ऐड हो गया, इसलिए वो 6 पे जा रहा है. Okay, let's show you another question. Let us say there is a wheel which is on a ground at rest. ठीक है, एक wheel ground पे रखा हुआ है and the wheel is at rest, and suddenly the wheel starts rolling, right? Suddenly the wheel starts rolling, it starts rotating and translating at the same time. So let us say the angular velocity of the wheel is equal to 3 radians per second, 3 radian per second, और इसका जो radius है, the radius is equal to 2 meters. Now as usual तुम t, c और s निकाल लोगे, t, c और b नीचे का point तुम निकाल लोगे. I'm asking you what is the velocity of a point that is located at 30 degrees above the horizontal? What is the velocity of a point that is located at 30 degrees above the horizontal? ठीक है, तुम्हें velocity निकालना है. As in you have to find out v in vector form. Normally, if you just write 5, you write 7, you write 6, you write 1, that's okay. But because this point is at an angle, तो इसका velocity along the x-axis या along the y-axis नहीं होगा. So you'll have to write it like, in vector form, I or j के form में. करो, you can pause the video, give it a try. How I would solve it is, first of all, I would find out the velocity of the center. और उसके बाद में किसी भी और point का velocity निकाल सकता हूँ. So I'll find out the velocity of the center. It's up to you to find out the velocity of the top point or not. उसके लिए हमें velocity of the bottom point भी चाहिए पड़ेगा. So because the surface is not moving, the velocity of the bottom point is also equal to 0, क्योंकि ये rolling motion है. In rolling motion, I've repeated this so many times. The velocity of the body is equal to the velocity of the surface, but at the point of contact, not everywhere, at the point of contact. So at the point of contact, velocity of the body is equal to 0. Body का velocity actually कितना है? The velocity of the body is equal to v. मान लेते हैं body का velocity v है. So velocity of the top point is also v. Velocity of the bottom point is also v. Velocity of this point is also v. Velocity of every point is v. क्योंकि object translate कर रहा है. In addition to that, the object is also rotating. तो ऊपर क्या होगा, आर ओमेगा ऐड हो जाएगा, नीचे क्या होगा, आर ओमेगा पीछे जाएगा, और सेंटर पॉइंट पे आर ओमेगा आएगा ही नहीं, जीरो. विल टॉक अबाउट पी के साथ क्या होगा, विल टॉक अबाउट पी इन जस्ट अ मिनट. लेकिन नीचे वाले पॉइंट पे आर ओमेगा पीछे जाएगा, सो यू कैन राइट प्लस वी माइनस आर ओमेगा इज इक्वल टू जीरो. सो बेसिकली v इज इक्वल टू आर ओमेगा, और r का वैल्यू 2 है, ओमेगा का वैल्यू 3 है, सो v इज इक्वल टू 6 मीटर्स पर सेकेंड. समझ में आया? मतलब ये जो तुम्हारा p वाला पॉइंट है, इस p वाले पॉइंट का फॉरवर्ड डायरेक्शन में जो वेलोसिटी है दैट इज 6 मीटर्स पर सेकेंड. दिस इज नोन. इमेजिन करो दैट समथिंग इज लाइक मूविंग इन सर्कुलर मोशन और इट इज जस्ट रोटेटिंग. किसी भी पॉइंट का वेलोसिटी कैसे होता है, इट इज ऑलवेज टेंजेंशियल टू द पाथ. तो इस पॉइंट में इसका जो वेलोसिटी होगा, बिकॉज ऑफ रोटेशन इट विल बी टेंजेंशियल टू द पाथ. तो आर ओमेगा ऐसे आएगा. तो आर ओमेगा कैसे आएगा यहाँ पे, इट इज गोइंग टू बी टेंजेंशियल टू द पाथ, सो दैट इज आर ओमेगा, एंड आर इंटू ओमेगा वी जस्ट फाउंड आउट इज अगेन 6 meters per second. Now the question is, this angle is 30 degrees, so what is that angle over there? ये angle कितना है? So there are several different ways of finding out कि वो angle कितना है. You could first of all say that, like, you know, you could draw an imaginary perpendicular line over here. You could say this angle is equal to 60 degrees, because 30 plus 60 is equal to 90. तो बचा हुआ एंगल यहाँ पे फिर से लाइक 30 डिग्री हो जाएगा. तो ये बचा हुआ एंगल यहाँ पे फिर हो जाएगा 60 डिग्रीज. ठीक है. देयर आर सेवरल डिफरेंट वेज ऑफ सॉल्विंग दिस. तुम और भी तरीके लगा सकते हो. तो दैट एंगल ओवर देयर इज इक्वल टू 60 डिग्रीज. दिस एंगल ओवर हियर इज 60. आई एम सेइंग सेवरल डिफरेंट वेज. तो और तरीके क्या है, और तरीका ये है कि जब अगर मान लो कि ये पॉइंट पी सामने होता, सो दिस एंगल वुड बी इक्वल टू 90 डिग्रीज. अगर ये पॉइंट ऐसे ऊपर होता तो दैट एंगल वुड बी इक्वल टू 0 डिग्रीज. तब मैं ये गेस करता कि अगर यहाँ पर है तो दिस एंगल इज इक्वल टू 90 माइनस थीटा. ठीक है, आई वुड गेस दैट वे. सो दिस एंगल इज 90 माइनस 30 विच इज इक्वल टू 60. नॉट गेस, दैट्स अ प्रीटी कैलकुलेटेड वे ऑफ सेइंग इट. ये 60 डिग्री है. अब हमें क्या करना है, इसको वेक्टर फॉर्म में बताना है. आइदर यू कैन फाइंड आउट द रिजल्टेंट. ठीक है, तुम इसका रिजल्टेंट निकाल सकते हो. कैसे निकालोगे, 6 का स्क्वायर प्लस 6 का स्क्वायर प्लस 2 इंटू 6 का स्क्वायर इंटू कॉस 60. और 60 कितना होता है, हाफ होता है. तो यू कैन जस्ट सिंपली से दैट दिस इज 3 टाइम्स 6 का स्क्वायर, which just makes it 6 root 3. So that is the magnitude of v net. So if the question is asking you what is the magnitude of the magnitude of the velocity is equal to 6 root 3. Now what is the component of the velocity, I और j फॉर्म में कैसे लिखोगे, तो you will write 6 meters per second सामने प्लस जो 6 meters per second इसका टेंजेंशियल है, तो उसका cos 60 वाला कंपोनेंट इसके साथ ऐड हो जाएगा, और इसका जो sin 60 वाला कंपोनेंट है वो नीचे लगेगा. सो दिस इज 6 sin 60 इन द डाउनवर्ड डायरेक्शन. You would get 6 cos 60. Cos 60 is just basically equal to half. Cos 60 का वैल्यू हाफ होता है. तो 6 plus 3 is equal to 9. आगे जा रहा है तो I cap. और जो नीचे जा रहा है sin 60, that's root 3 by 2. So that's minus 3 root 3 j cap. So this is your velocity vector of that point P. So what is the velocity of point P अगर कहीं पे आता है और आ भी चुका है, it has come in some mains exams like किसी एक दो साल में तो ये एग्जाम आया है या ये क्वेश्चन आया है. So the velocity of point P is 9I minus 3 root 3j. Okay. I've given you so many questions on rolling. एक आध क्वेश्चन अपन स्लाइडिंग पे करते हैं, फिर we'll come back to rolling once again. So one question is, imagine that there is a wheel. Once again, there is a wheel, and the wheel is on a flat surface. The wheel is on a flat surface, and the speed of the wheel is, let's say, 8 meters per second. Some value. Okay. The radius of the wheel is equal to 3 meters, and the angular velocity of the wheel is equal to 3 radians per second. So is the wheel rolling or sliding? First question, is the wheel rolling or sliding? तो व्हील रोल और स्लाइड कर रहा है कि नहीं कर रहा है, ये डिसाइड करने के लिए ऑलवेज बी साइंटिफिक. से दैट द वेलोसिटी ऑफ द बॉडी is equal to the velocity of the surface at the point of contact. If the wheel is actually rolling or if the wheel is actually sliding, either way जो भी हो रहा है, the wheel is rolling or the wheel is sliding. So if the wheel is rolling, then at the point of contact the velocity of the body should be equal to the velocity of the surface. The velocity of the surface is equal to 0. So the velocity of the body should also be equal to 0. Should be. अब देखते हैं होता कितना है. तो यहाँ पे कितना है? This is 8. And because of rotational motion, इसका backward direction में velocity हो जाएगा r into omega, which is equal to 9. So the velocity of the body is v minus r omega, which is minus 1. So it is not equal to 0. Therefore, your object is sliding or your object is slipping. तो प्रैक्टिकली स्पीकिंग यहाँ पे क्या हो रहा है? यहाँ पे व्हील जितने स्पीड से आगे जा रहा है, द रेट एट विच द व्हील इज गोइंग फॉरवर्ड, उससे ज़्यादा स्पीड से व्हील रोटेट कर रहा है. द रोटेशनल स्पीड ऑफ द व्हील इज मच मोर देन द लाइक द स्पीड एट विच द व्हील इज मूविंग. So that is why the wheel is sliding on the surface. ठीक है, व्हील स्लाइड कर रहा है. ठीक है, व्हील स्लाइड कर रहा है. तो व्हाट इज द वेलोसिटी ऑफ द टॉप पॉइंट एंड व्हाट इज द वेलोसिटी ऑफ द बॉटम पॉइंट? तो बॉटम पॉइंट का तो वेलोसिटी निकाल चुके हैं. द बॉटम पॉइंट वेलोसिटी इज इक्वल टू +8, सामने जाने का स्पीड, और रोटेशनल मोशन की वजह से यू विल बी गोइंग बैकवर्ड्स, तो -9, इट इज इक्वल टू -1 मीटर्स पर सेकेंड. मतलब जो नीचे वाला पॉइंट है वो एक्चुअली थोड़ा पीछे जा रहा है. What about the top point? The velocity of the top point is equal to 8 plus 9, which is equal to 17 meters per second. कंपेयर दिस टू रोलिंग. जब रोल होता है तुम्हें अगर याद होगा, इसका वेलोसिटी अगर v है तो इसका वेलोसिटी होता है 2v और इसका वेलोसिटी होता है 0. तो दैट इज व्हाट हैपेंस व्हेन समथिंग इज रोलिंग. तो यहाँ पे इसका वेलोसिटी 2v से थोड़ा ज़्यादा है और इसका वेलोसिटी 0 से थोड़ा कम है. So basically, whenever something is like, sliding on a surface, or it is moving like this, so that the velocity of the body is not the same as the surface. Okay? Condition, sliding, the surface, the object is sliding. Sometimes what they'll ask you is, okay, something is moving like this, something is rotating, something is also translating. At the beginning of this chapter, I told you there is something that's called as the instantaneous axis of rotation. एक चीज होता है जिसको कहते हैं instantaneous axis of rotation. The instantaneous axis of rotation कैसे निकालेंगे? How do you find out what is the instantaneous axis of rotation? So I told you at that time, I'll also repeat this right now. How to find the instantaneous axis of rotation? Instantaneous axis of rotation. So what is an instantaneous axis? What is an axis? An axis of rotation is a point that stays at rest. The important thing about an axis is that ये जो point है, ये point हमारा rest पे रहना चाहिए. That is what is important about an axis. So if something is rotating, for example, if the door is swinging open, तो उसका जो axle है वो rest पे रहना चाहिए. तो इंस्टेंटेनियस एक्सिस ऑफ रोटेशन एक ऐसा पॉइंट है जिसका स्पीड 0 है. इस केस में ट्राई करते हैं, जो ऑब्जेक्ट स्लाइड कर रहा है इसका इंस्टेंटेनियस एक्सिस ऑफ रोटेशन कहाँ पर है. एक तो हमें ये पता है कि दी एंटायर व्हील इज रोटेटिंग अबाउट द सेंटर. ठीक है, तो वो इसका एक्सिस ऑफ रोटेशन हो गया, लेकिन इट्स नॉट एट रेस्ट, इट्स मूविंग एट 8 मीटर्स पर सेकेंड. हमें एक ऐसा पॉइंट निकालना है विच इज एक्चुअली एट रेस्ट. So let us say that point is at a distance of x from the center. x नीचे भी हो सकता है, x सामने भी हो सकता है, x ऊपर भी हो सकता है, लेकिन थोड़ा सा भी तुम दिमाग लगाओगे तो x जो तुम्हारा पॉइंट है, वॉट एवर पॉइंट x यू आर टेकिंग, द वेलोसिटी इन द फॉरवर्ड डायरेक्शन इज ऑलवेज गोइंग टू बी 8. जो भी तुम्हारा पॉइंट x है, कहीं पे भी लोगे, नीचे भी लोगे, ऊपर भी लोगे, उसका सामने डायरेक्शन में वेलोसिटी 8 आएगा. अब तुम्हें वेलोसिटी को जीरो करना है. यू वांट टू मेक द वेलोसिटी जीरो. So you need to put a 8 in the backward direction, not in the forward direction. तो अगर तुम ऊपर रखोगे तो इसको सामने के डायरेक्शन में 8 मिलेगा और रोटेशन की वजह से भी सामने मिल जाएगा. So this point is not possible. Obviously point यहाँ पे नीचे होगा and it will be at such a point such that r का वैल्यू x है और ओमेगा का वैल्यू like is omega 3 रेडियंस पर सेकेंड. तो सामने 8 और पीछे x omega, it just adds up to 0. So plus 8 minus x omega is equal to 0. X is not the radius of the wheel. So 8 is equal to x into omega, which implies that x is equal to 8 by 3 meters. तो व्हील का रेडियस 3 मीटर है, लेकिन जो इंस्टेंटेनियस एक्सिस ऑफ रोटेशन है, अगर ये गाड़ी है जो भी चीज़ें तुम्हारे सामने अगर जाता तो तुम्हें ये व्हील का पॉइंट क्लियरली दिखाई देता, बिकॉज दिस पॉइंट इज नॉट स्लाइडिंग और मूविंग और डूइंग एनीथिंग एट ऑल, इट इज एट रेस्ट. तुम्हें पॉइंट बिल्कुल स्टिल दिखाई देता. तो दैट इज योर इंस्टेंटेनियस एक्सिस ऑफ रोटेशन. एक्स इज इक्वल टू 8/3 मीटर्स. मतलब फ्रॉम द एक्सिस इट्स 8/3 मीटर्स नीचे. ठीक है, ओके, लेट्स ट्राई दिस अगेन. जब कोई चीज रोल कर रहा है, whenever something is rolling, what is its instantaneous axis of rotation? General question. Whenever anything is rolling, what is its instantaneous axis of rotation? Pause it right now. इसको एक बार तुम खुद से ट्राई करो, फिर उसके बाद मैं तुम्हें बताता हूँ. Imagine that something is rolling. Where or what is its instantaneous axis of rotation? तो मान लेते हैं समथिंग इज मूविंग विद द स्पीड ऑफ v, कुछ तो गिवन नहीं है। तो लेट अस से द रेडियस इज इक्वल टू r, लेट अस से द एंगुलर वेलोसिटी इज ओमेगा, सब लेट, क्योंकि क्वेश्चन में कुछ भी नहीं गिवन है। इट इज मूविंग ऑन अ सर्फेस, तो व्हाट इज इट्स इंस्टेंटेनियस एक्सिस ऑफ रोटेशन, क्वेश्चन ये पूछ रहा है। तो let us say the instantaneous axis of rotation is at a distance of x. There are two ways to solve this. First way is to just understand कि ऐसा कौन सा पॉइंट है जो रेस्ट पे रहता है। सरफेस तो मूव कर नहीं रहा है, तो इसका बॉटम वाला पॉइंट रेस्ट पे रहेगा। सो ऑब्वियसली द वेलोसिटी ऑफ द बॉटम पॉइंट इज इक्वल टू जीरो, देयरफॉर द बॉटम पॉइंट इज द इंस्टेंटेनियस एक्सिस ऑफ रोटेशन। सीधे सीधे। लेकिन जिनको ये चीज़ नहीं पता है, लाइक यू नो दोज हु प्रेफर अ लॉजिकल वे ऑफ सॉल्विंग समथिंग, तो मान लेते हैं कि उसका डिस्टेंस x है। तो इस पॉइंट का वेलोसिटी जो होगा वो v होगा, और बैकवर्ड डायरेक्शन में इसका जो एंगुलर वेलोसिटी होगा, हमेशा जरूरी नहीं है कि बैकवर्ड डायरेक्शन में होगा, हो सकता है समथिंग इज रोटेटिंग इन द ऑपोजिट डायरेक्शन, फिर ऊपर लोगे। तो मैंने समझा दिया कि तुम्हें ऑपोजिट डायरेक्शन में लेना है, ऐसे लोग कि इसका जो ट्रांसलेशनल कंपोनेंट है और रोटेशनल कंपोनेंट है, दे शुड बी इन ऑपोजिट डायरेक्शंस। So this is x, so this velocity will be x omega. So you can write plus v, right, minus x omega is equal to 0. Plus v minus x omega is equal to 0. So v is equal to x into omega. ये पहला रिलेशन है। अब दूसरा चीज, बिकॉज द ऑब्जेक्ट इज रोलिंग एट द बॉटम पॉइंट इट इज v, and in the backward direction it is r omega. So we can write plus v minus r omega is equal to the velocity of the surface. The velocity of the surface कितना हो जाएगा, यहाँ पे जीरो है, कहीं और पे जीरो नहीं होगा, तो this will give you some value. So that is why I'm showing you the general method. So v will be equal to r omega. Now you take this value and put it over there. So r omega is equal to x omega. That is why x is equal to r. R omega is equal to x omega and x is equal to, तो जब भी कोई ऑब्जेक्ट रोल कर रहा है ऑन अ सरफेस एट रेस्ट, वेन एवर एन ऑब्जेक्ट इज रोलिंग ऑन अ सरफेस एट रेस्ट, so there are a few conditions to this, इसलिए it's not a very general statement. If an object is rolling on a surface at rest, then the instantaneous axis of rotation is the point of contact with the surface. Is rolling on a surface at rest, then the instantaneous axis of rotation, the instantaneous axis of rotation is the point of contact. It is the point of contact with the surface. It is the point of contact with the surface. Okay, let's try another question. I hope तुम्हें ये सब चीज़ समझ में आ रहा है. As always, keep in mind if you don't understand something, leave a comment or you can drop a message in the group as you do. So let's try another question. Let us say that there is a wheel. We have done this question even before. Let us say there is a wheel between two planks. तो यहाँ पे एक plank है ऊपर, एक plank नीचे है. मान लेते हैं इसका speed is like that day we took 5 meters per second, लेकिन वो नीचे का speed था, तो इसको 3 meters per second. This is 5 meters per second. And let us say the radius of this thing, which is the diameter इसका जो है, that is 2 meters. So the radius is 1 meter. So the question that day was to find out ki what is the velocity of the center point. We found out, I think the velocity was equal to -1, it was coming. Okay? And what is the angular velocity of this thing? So the angular velocity of this thing I think was 4 or something. I don't exactly remember. So angular velocity bhi nikalna hai. So I'm also going to find out v along with it. In addition to all of these things, you need to find out the instantaneous axis of rotation of this cylinder. So the new thing over here in today's problem is to find out the instantaneous axis of rotation. Find out the instantaneous axis of rotation. Find that. So let's start solving. As usual, you first find out the value of v, omega, and then you find out the instantaneous axis. वो कहीं पे भी हो सकता है, तो I'll just assume that the instantaneous axis is slightly towards the top. think I'll just assume. I don't know, so it will be slightly towards the top, which might be a very stupid choice because ये v की तरफ it's going to move forward with the speed of v, and also it is going to have a rotational velocity of x omega. तो चलेगा, okay? I mean, in general, when you cannot decide, then how would you sit down and guess? So don't spend your time guessing. Just assume some point and let the maths do its magic. Okay? So let us take the top point. तो इसका जो टॉप वाला पॉइंट है, इसका वेलोसिटी कितना होगा? वी ऑलरेडी नो दिस, वी हैव डन दिस सो मेनी टाइम्स. v प्लस एक्स ओमेगा होगा, आर ओमेगा होगा, आई एम सॉरी, v प्लस आर ओमेगा. Velocity of the bottom point, the velocity of the bottom point will be equal to v minus r omega. The velocity of the top point is equal to plus 3 because we're taking the rightward direction is positive, so it is plus 3. The velocity of the bottom point is equal to minus 5. That day, actually, what I did was I did it in the same way, but I did it slightly different. I just said the r omega is in the same direction as 5, so we can write 5 is equal to r omega minus v. Same thing. Now, if you see, if you multiply this by minus 1, you'll get the same answer. So just keep your logic straight. What is positive, just keep that straight, and you'll be able to solve the problem without any flaw. Normally, what I do is I take the direction of motion is positive. That day, just to simplify it, I showed you that 5 is equal to r omega minus v. So v plus r omega is 3, v minus r omega is minus 5. So you subtract this, then you'll get that 2r omega is equal to 8. So omega is equal to 8 divided by 2r. The 2r is equal to 2, that is 4 radians per second. Diameter 4 radians per second. अब इन दोनों को तुम ऐड करो तो इफ यू ऐड बोथ ऑफ इट तो यूल गेट 2v इज इक्वल टू -2 और v इज इक्वल टू -1 meters per second. That is the velocity. Now let's come to this point. Instantaneous axis of rotation निकालना है तो at that point plus v plus x omega is equal to 0. ठीक, क्योंकि the instantaneous axis of rotation is a point that stays at absolute rest. So v is equal to -1, x I don't know, and omega is equal to 4. So this is 0, which means that 4x is equal to 1 or x is equal to 1 by 4 meters. So the instantaneous axis of rotation in this problem is a point that is 25 centimeters above the central axis. So इसका जो भी central axis है, which is moving backwards with a speed of -1 meters per second, 25 centimeters above that point, there is a point which is at absolute rest. That is why that point is the instantaneous axis of rotation. ठीक है, तो आई होप सबको समझ में आ गया होगा. आई डोंट थिंक देयर विल बी एनी प्रॉब्लम्स ओवर हियर. यू मस्ट हैव अंडरस्टूड. कुछ और प्रॉब्लम्स करते हैं, सम मोर प्रॉब्लम्स, एंड देन यू कैन जस्ट सिट डाउन एंड स्टार्ट सॉल्विंग दीस प्रॉब्लम्स एंटायरली ऑन योर ओन. Let us say there is a big wheel, and on this wheel there is a smaller wheel, and this smaller wheel is actually resting on a surface. On the top part of this wheel there is a thread. Somebody is pulling the thread at 2 meters per second. The radius of this part is equal to 1 meter. The radius of that part is equal to 3 meters. Somebody is pulling that thread at a speed of 2 meters per second. Your question is to find out the velocity of a few different points. Find the velocity of the top part of the wheel, find the velocity of the bottom part of the wheel, and find the velocity of the front part of the wheel. Find the velocity of the top, find the velocity of the bottom, and find the velocity of the front part of the wheel. Question समझ में आया? There is a thread that is wound on a smaller part of this wheel. So this wheel has basically two surfaces. थोड़ा सा like it's cut out and it has a surface like this. So this surface is lying on a plane, on a plank or something, and it is rolling. The thing is rolling. They are pulling the thread at 2 meters per second. Find the velocity of the top part, find the velocity of the bottom part, and find the velocity of the front part. At this point, you should be able to do it. One of the reasons why I'm stressing on rolling so much is because, in my opinion, it is one of the most fundamental, or it is one of the most central concepts in rotational mechanics, rotational dynamics. We don't teach it first because to study this, we need to talk about so many other things, कि object क्या होता है, rolling क्या होता है, and all that stuff, rotation क्या होता है. But rolling is one of the things that should be taught first. It's one of the most central things in this chapter. Almost everything else, it rotates around this idea of rolling. So initially we started doing V is equal to R omega, A is equal to R alpha, but they are true only in very basic conditions. In advanced conditions like this one, you can't just say V is equal to R omega. You'll have to calculate. तो इस चीज पे like we have stressed in last class, today's class, I think I expect कि तुम्हें बड़े अच्छे से आना चाहिए. Next class onwards, we'll start doing angular momentum, like I said. Anyway, so what about this case? The velocity of this point is 2 meters per second. So normally this would be our top point. We can't write it as t, so I'll write it as small t. Let us say the velocity of the center is v, and let us say the angular velocity of this entire wheel is omega. First of all, you understand that if the wheel has an angular velocity of omega, the inner wheel also has an angular velocity of omega. They both have the same angular velocity omega. Okay? बाहर का व्हील का अगर एंगुलर वेलोसिटी ओमेगा है तो द एंटायर व्हील इज रोटेटिंग टुगेदर, सो द इनर व्हील आल्सो हैज एन एंगुलर वेलोसिटी ऑफ ओमेगा. तो बाहर का भी ओमेगा है, इनर का भी ओमेगा है. Now you need to find out omega. So you do that by saying कि the velocity of this point Vt, our top point, is equal to V plus 1 meter into omega, smaller 1 into omega. The velocity of the bottom point, which is in contact with the plank, is at rest. So it is Vb. So V small b is equal to V minus 1 into omega, and the plank is at rest, so that is equal to 0. ठीक है, so v minus 1 omega is equal to 0. So you can write v is equal to 1 omega. तो जैसे ही तुम इसको लिखोगे you can come to this point and you can write that 2 times omega, 1 into omega is just omega, so 2 times omega is equal to the velocity of the top point. The velocity of the top point is given to us is 2 meters per second. तो इसको कैंसिल कर दो तो ओमेगा का वैल्यू कितना आएगा, 1 रेडियन पर सेकेंड, मीटर्स पर सेकेंड नहीं, क्योंकि यहाँ पे एक मीटर भी था, है ना, 1 मीटर इंटू ओमेगा, तो ये आएगा 1 रेडियन पर सेकेंड. The omega is 1 radians per second. Now we can go and find whatever we want. So let's first find out the velocity of the top point. तो इस पॉइंट का भी जो स्पीड होगा, द स्पीड ऑफ दिस पॉइंट इज ऑल्सो v. द स्पीड ऑफ दिस पॉइंट इज ऑल्सो v. द स्पीड ऑफ दिस पॉइंट इज ऑल्सो v. ठीक है, द एंटायर थिंग इज ट्रांसलेटिंग. तो हर एक पॉइंट का इस पूरे व्हील पे स्पीड v होगा, चाहे तुम्हें जितना भी अजीब लगे. द स्पीड ऑफ एवरी पॉइंट ऑन दिस व्हील इज v. वो रोटेट कर रहा है, ये बात अलग है, but the speed of every point on this wheel is equal to v. Now, the next thing, it is also going to have a rotational component. So it is going to be r omega over there. यहाँ पे tangentially होगा, I explained this thing to you. So that is going to be r omega. और यहाँ पे backward direction में होगा, and that is equal to r omega. That is downwards, this is backwards, that's forward. So velocity of the top point is equal to v, which is, we found out v is equal to 1 into omega. Omega is equal to 1 radian per second. So v is just 1 meter per second. यहाँ पे लिख देते हैं v is 1 meters per second. So v is equal to 1 plus the value of r into omega. So what is the radius of the outer part? 3 meters. The radius of the outer part is equal to 3. So 3 times omega, which is 1 radians per second. तो वो आएगा 4 meters per second. So the velocity of the top part is equal to 4 meters per second. How about the bottom part? The velocity of the bottom part is equal to plus v. So plus v is 1 minus r into omega. So 1 minus 3 is minus 2 meters per second. The velocity of the bottom part is minus 2. मतलब पीछे की तरफ 2 meters per second. And finally, what is the velocity of the front part? तो ये तुम अभी खुद से निकाल लोगे. R into omega is equal to 3. V is equal to 1. So velocity of the front part is 90 degrees wala combination. So 1 square plus 3 square ka root over, which is equal to root over 10 meters per second. The velocity of the front part is equal to root over 10 meters per second. Okay? So there are 3 points. There's the top of the wheel, there's the bottom of the wheel, and there's the front part of the wheel. The front part का velocity आएगा root over 10 meters per second. Bottom part का आएगा 2 meters per second पीछे, और front part का like the top part का आएगा it is 4 meters per second आगे. ठीक है? So we have done quite a bunch of problems on rolling motion. Let's try to do some problems based on force. So these problems are based on basic rolling motion. I wanted you to find out the velocity. I wanted you to find out the velocity of different points. They also ask you what is the acceleration. So we can do that later. That's not required right now. That has something to do with circular motion. So we can do those problems slightly later. Let's do some problems based on force. So what is the acceleration of an object that is rolling down an inclined plane? I think we kind of did this question in the last class. What is the acceleration of an object that is rolling down an inclined plane, which is rolling down an inclined plane? So one of the reasons I'm doing this is just to give you a feel for drawing all the forces once again. And then we can do a separate problem based on this. You'll see. So imagine that there is an object that is rolling down an inclined plane. So whenever something is rolling, there has to be friction. Q. Why is friction required? Because this point of contact between the body and the surface, it somehow has to be addressed. So what does friction do? Friction opposes motion and keeps the object at rest, or at least it prevents motion if it can. If it cannot, there is going to be sliding. But as far as it can, it will prevent motion. So that is why on a very, very smooth surface, you cannot have rolling motion. You can, I mean, it's not essential that you cannot, but normally it will not be possible. If you keep a sphere on a very smooth surface and you kick it, the sphere will not roll. It will start sliding. But if the sphere is already rotating and then you move it, then it is possible that at some point the motion will become rolling. अपन उस वाले कॉन्सेप्ट पे भी जाएंगे इन सम अमाउंट ऑफ डिटेल बट अभी के लिए ध्यान में रखो कि फ्रिक्शन इज रिक्वायर्ड फॉर रोलिंग मोशन टू हैपन सो ओवर हियर फ्रिक्शन हैज टू एक्ट इन द बैकवर्ड डायरेक्शन हाउ डू यू डिसाइड दिस अच्छा if friction was not acting always to decide the direction of friction keep in mind what will happen if friction was not present if friction was not present this point would have moved in the forward direction so friction will oppose the motion that would have happened अगर friction नहीं होता तो अगर friction नहीं होता ये point आगे move करता that is why friction is going to act in the backward direction so in this case the case that we have over here friction is going to act in the backward direction it's going to act पीछे now there is gravity so there is mg acting in the downward direction there is obviously normal force the normal force is acting in the upward direction over here and there is a component of gravity because of which this entire wheel is rolling so that is mg sine theta there is a component of gravity because of which the wheel is rolling so mg sine theta की वजह से wheel आगे जा रहा है now you write down the equation for linear motion of this thing the linear motion is a rotational motion of this thing is equal to alpha so for linear motion you can write ma is equal to plus mg sine theta ma is equal to plus mg sine theta minus f linear motion जो भी है तो ma is equal to mg sine theta minus f now, for the rotational motion, take the axis of rotation as center of mass. मैंने समझाया always take axis of rotation as center of mass. So you will write I into alpha. So the moment of inertia of this wheel is I, the mass is m, and the radius is r. These facts are given, or you can assume them. These facts are there. So I alpha is equal to plus r into f. Now, because you've seen it in the last class, you know how to solve this. So f is equal to I divided by r into alpha we still need a relation between a and alpha so because this thing is rolling we can write a is equal to r alpha that is because this entire object is rolling so instead of alpha over here so we can write alpha is equal to a divided by r तो यहाँ पे alpha की जगह पर you can write a by r तो a by r square हो जाएगा put it over there so ma is equal to mg sine theta minus f which is equal to ia divided by r square इसको इधर ले आओ तो a into m plus I divided by r square is equal to mg sine theta so you can write A is equal to mg sine theta divided by m plus I by r square. Just like I showed you in the last class, you can divide the entire thing by m and you can write g sine theta divided by 1 plus I by mr square. So this problem is both a reminder and it's also a revision of how to write down the forces and how to solve the entire thing. One thing I want to add over here, or actually a couple of things I want to add over here. If you notice, we never wrote that F is equal to mu into N. In fact, we even did not use the normal reaction. That is because F is not equal to mu into N. Why? Because if you remember the graph for friction, F is equal to mu into N only when an object is sliding. Is our object sliding? No, it's rolling. So because the object is rolling, F is not equal to mu into N. ध्यान रखना. So when you go for exams like KUPY and NACP, you'll have interviews and they'll ask you questions like this. Or even in advance, you'll have assertion reason questions kind of thing. Like, assertion is this, reason is the reason the correct one for the assertion? So assertion reason questions में ये पूछते हैं. Concept should be clear. So F is not equal to mu n because F mu n के बराबर तभी होता है when an object is sliding or it is just about to slide. तो यहाँ पे वो नहीं हो रहा है यहाँ पे our object is rolling. So F is not equal to mu. What is the value of F? The value of F can be found out by solving whatever we have over here. So let's first erase this. यहाँ से हम लोग F निकाल सकते हैं. What is the value of F? F is equal to mg sin theta minus ma और a का वैल्यू कितना है g sin theta divided by 1 plus I by mr square. taking the value that I found out over here. So you can just take mg sin theta common. ठीक है, mg sin theta को तुम common ले लो, and then you just basically subtract. So you will get I divided by mr square divided by 1 plus I by mr square. So it's just a very good practice to, like, keep everything in the denominator as far as possible, so you can predict what will happen if the mass changes and all. तो ये हो जाएगा 1 plus mr square divided by I. ठीक है, बात समझ में आया? So if the mass increases, the bottom factor over there is not going to change because the moment of inertia also has mass, it's going to cancel. So if the mass increases, the friction will also increase. So heavier objects are going to require a greater amount of friction, and lighter objects are going to require a smaller amount of friction. Okay, that's the first thing. What is the coefficient of sliding friction required so that the object can roll? What is the coefficient of sliding friction? Mu कितना चाहिए so that the object can roll? तो पहले तो निकाल लो, ये फ्रिक्शन है, दिस इज mg sin थीटा by 1 plus mr square plus mr square by I. तो फ्रिक्शन कितना रिक्वायर्ड है so that the object can roll? If the object has to roll, the friction has to be lesser than the maximum possible friction. तो फ्रिक्शन कितना है? mg sin theta divided by 1 plus mr square by I. This is the amount of friction that we have or we require for it to roll. Maximum friction कितना है? Maximum friction is equal to mu into normal reaction. तो what is normal reaction? Normal reaction ऊपर लग रहा है और mg का एक component नीचे लग रहा है, mg cos theta. So they should balance each other. So you will write plus n minus mg cos theta is equal to 0. So n is equal to mg cos theta. करेक्ट, समझ में आया? तो mg को यहाँ से कैंसिल कर दो. तो इफ यू सॉल्व, म्यू शुड बी ग्रेटर देन tan theta divided by 1 plus mr square by I. So the coefficient of friction must be more than tan theta by 1 plus mr square by I. इतना coefficient of friction तुम्हें चाहिए. अगर इससे कम coefficient of friction तुम दोगे तो क्या हो जाएगा? If you provide coefficient of friction less than this for any specific object, then the surface will be too smooth. बहुत smooth हो जाएगा surface, and the object instead of rolling, it will start slipping. तो अगर तुम्हें ऑब्जेक्ट को रोल कराना है तो दिस इज द मिनिमम अमाउंट ऑफ फ्रिक्शन दैट यू शुड प्रोवाइड so that the thing starts rolling. So you'll be given different objects. For example, if I can give you a sphere, or if I, for example, will give you a ring, so they'll ask you what is the coefficient of friction. तो अगर तुम्हें for example एक sphere दिया हुआ है तो what will you do? You'll write mr square divided by 2 by 5 mr square. So that just makes it 5 by 2, or 5 by 2 plus 1. That makes it 7 by 2. So your answer over here will be equal to 2 by 7 tan theta. In fact, ये question भी advanced में आया है. So what is the coefficient of friction required for a sphere to roll down an inclined plane? 2 by 7 tan theta. So you solve questions based on this understanding कि फ्रिक्शन का जो मैक्सिमम वैल्यू है वो रीच नहीं होना चाहिए if the object has to keep rolling. If the object slides, then the maximum value of friction should act. Okay, so small concepts are required. Let's show you another problem on rolling, but forces are involved. Let's try to solve this problem also. There is a flat surface and there is a pulley. Apna pulley massless hai, so this pulley is not going to come in our calculation. But connected to this pulley, there is a mass, and this mass could be anything. M, radius is r, moment of inertia is I. तो इसका जो radius है that is r, moment of inertia is I. और इसके साथ there is a block that is connected, and the mass of the block is also equal to m. The question is, what is the acceleration of this block? Block का acceleration क्या है? ठीक है, क्वेश्चन समझ में आया? There is a massless pulley, so this pulley is not going to be a part of our calculation. It only just bends the rope. The rope is connected to a mass like this. The mass can rotate, it can also move forward, so this mass is basically rolling. And on the other side you have the same mass, but that is simply hanging. तो वो mass जब नीचे जाएगा तो ये mass roll होके आगे जाएगा, and you need to calculate what is the acceleration of that hanging mass. All right. So let us say the acceleration of that hanging mass is a. Step by step जाते हैं. So if the acceleration of the hanging mass is a, first of all इसके rolling चीज के साथ deal करेंगे. Let's deal with the rolling part. तो इसके ऊपर वाले point का acceleration a होगा. Surface तो rest पे है. So this point will have no acceleration at all, zero, because that point is at rest. ये जो मिडिल पॉइंट है इसका एक्सेलरेशन मेरे को नहीं पता, सो आई जस्ट राइट कैपिटल ए एंड लेट अस से द एंगुलर एक्सेलरेशन इज इक्वल टू अल्फा. So the acceleration of the top point is a plus r into alpha, which is equal to a, and the acceleration of the bottom point is a minus r alpha, which is equal to 0. We have already done this so many times. ये तुम्हें आना चाहिए. तो a plus r alpha is a minus r alpha is 0. So a is basically equal to r alpha, and if you put it in the first one, 2r alpha is equal to a. So alpha is equal to a divided by 2r. A is not equal to r alpha. ठीक है, ए इज इक्वल टू 2r इंटू अल्फा. तो अलग अलग हो सकता है, ये चीज़ ध्यान में रखो. ए इज इक्वल टू आर अल्फा इज अ वेरी बेसिक एप्लीकेशन. तो इसलिए मैंने बोला था रोलिंग बाद में पढ़ाते हैं, उसके बाद द गुड प्रॉब्लम्स कम अप. सो दिस इज अ गुड वन. इट्स नॉट कॉम्प्लिकेटेड बट इसमें दो तीन कॉन्सेप्ट्स लग रहे हैं. तो अल्फा इज इक्वल टू ए बाई टू आर. ठीक है, फटाफट. तो व्हाट इज द एक्सेलरेशन ऑफ द सेंटर? देन ए इज इक्वल टू आर इंटू अल्फा. तो ए इज इक्वल टू ए बाई टू. तो वी हैव टू थिंग्स. ये जो तुम्हारा व्हील है, दिस व्हील इज मूविंग फॉरवर्ड. It is rolling, so the wheel is moving forward with an acceleration of a by 2. That is a, so this is a by 2. And its angular acceleration is a divided by 2r. ये दोनों चीज हमें पता है. Now, what other forces are acting? यहाँ पे टेंशन लग रहा है. Friction is required, so यहाँ पे friction लग रहा है पीछे के direction में. Same tension is acting over here because this pulley is not rolling. So that is the same tension over here. और यहाँ पे नीचे के direction में mg लग रहा है. He think f is not equal to mu n. This is one mistake that kids make. That's not wrong. ठीक है, तुम लोग करते हो क्योंकि f is equal to mu n लिखने का आदत है. लेकिन f is not equal to mu n because an object is rolling. F is equal to mu n if an object is slipping or if an object is sliding. इसलिए उसको sliding friction कहते हैं. It is rolling, so you must have read at that time in school कि rolling friction is less than sliding friction. That's what I'm saying. ठीक है, mu n से कम है. It's not mu n. So a is equal to a by 2. Now we need to write equations. So the first equation we'll be writing for this rolling object over here. So plus t minus f is equal to m. इसका acceleration कितना है? a by 2 है. तो जो acceleration है वही लिखेंगे. अब इसके center of mass को ले लो. तो ये center of mass है इसका. तो what will you write? What is the torque? The torque is plus tr plus fr. They are both helping. This is also helping. That is also helping. Is equal to I alpha. ठीक है, तो यू कैनॉट जस्ट सब्स्टिट्यूट अल्फा इज इक्वल टू ए बाय आर एंड ऑल. तो देख के हम लोग को सब्स्टिट्यूट करना पड़ेगा. पहले इक्वेशन लिख लेते हैं. सो दिस इज द इक्वेशन फॉर स्ट्रेट लाइन मोशन. दिस इज द इक्वेशन फॉर रोटेशनल मोशन. नाउ विल राइट एन इक्वेशन फॉर दिस वन. सो प्लस एम जी माइनस टी इज इक्वल टू एम ए. इसका स्ट्रेट लाइन मोशन. अब इसको सॉल्व करने का कोशिश करते हैं. लेट्स डिवाइड द सेकंड इक्वेशन बाय आर. फर्स्ट इक्वेशन इज टी माइनस एफ इज इक्वल टू एम ए बाई टू. सेकेंड इक्वेशन को आर से डिवाइड करते हैं तो टी प्लस एफ इज इक्वल टू आई इंटू अल्फा बाई आर हो जाएगा. दोनों को आप ऐड कर देते हैं. तो यू विल गेट टू टी इज इक्वल टू एम ए बाई टू प्लस आई अल्फा बाई आर. तो यहाँ से हमें टी मिल जाएगा. टी को अपन इसमें सब्स्टिट्यूट कर देंगे. तो व्हाट इज टी? टी इज इक्वल टू हाफ ऑफ दैट मच. यू रिमूव द टू फ्रॉम हियर एंड देन यू पुट अ टू ऑन द अदर साइड. सो टी इज इक्वल टू हाफ ऑफ दैट मच. तो यहाँ पे लिखो प्लस एम जी माइनस टी. तो टी का वैल्यू हो जाएगा हाफ ऑफ एम ए डिवाइडेड बाई टू प्लस आई अल्फा डिवाइडेड बाई आर. एम ए बाई टू प्लस आई अल्फा बाई आर, दैट इज द वैल्यू ऑफ टी. ठीक है, so this is equal to ma. अब हमें ma सॉल्व करना is like very easy. We just need to take this term to the right. What is the value of alpha? Alpha is equal to a by 2r. तो let's substitute. Alpha is equal to, यहाँ पे alpha जो है इसको हटाते हैं. Let's remove alpha and let us put a divided by 2r. तो a divided by 2r already है, तो it will become 2r square. Now move this entire term to the right. So you'll get mg is equal to half of, I forgot क्या होगा, ma by 2 plus ia by 2r square. ma divided by 2 plus ia divided by 2r square plus already वहाँ पे क्या था? ma था. ma was already there. So you'll get mg is equal to ma by 4 plus ia divided by 4r square plus ma. Take a common. ठीक है, this will become 5 ma by 4 plus ia by 4r square. Now you multiply the entire thing by 4, so you'll get 4 mg is equal to 5 m plus I by r square into A. So A is equal to 4 mg divided by 5m plus I by r square. If you want, you can divide by m. So you'll get 4g divided by 5 plus I by mr square. That's because the mass of the block and that object, they are the same. In दोनों का mass same है. So, समझ में आया? Did you understand this problem? This problem involves rolling as well as translational motion. ठीक है, तो हमने सबसे पहले रोलिंग के इक्वेशंस को लिखे यहाँ पे, लाइक वी रोट डाउन ऑल द इक्वेशंस दैट वी हैव लर्नड अबाउट रोलिंग सो मेनी टाइम्स. While doing those equations, you might have thought, why can't I just write A is equal to R alpha? You can't, because always it is not going to be the same. ठीक है, always it's not going to be the same. फिर उसके बाद alpha is equal to a by 2r, we derived from those equations. A is equal to a by 2, ये center of mass का है. This is the acceleration of the center of mass, because that is what we take in a calculation. We can't take the acceleration of the top point or the bottom point. Whenever something is moving, then we take the acceleration of its center of mass. If all of it is moving with different speeds, then we take the acceleration of center of mass and the rotational acceleration. तो यही अपना आइडिया है. दिस इज द फंडामेंटल आइडिया ऑफ दिस चैप्टर. अगर पूरा ऑब्जेक्ट सेम तरीके से मूव कर रहा है, देन वी चूज द एक्सेलरेशन ऑफ द सेंटर ऑफ मास. अगर एक पार्ट ज्यादा मूव कर रहा है, एक पार्ट स्लो मूव कर रहा है, देन इन एडिशन टू दैट वी आल्सो चूज द एंगुलर एक्सेलरेशन. दैट इज द वे वी सॉल्व प्रॉब्लम्स. पूरा ऑब्जेक्ट अगर एक ही स्पीड से मूव कर रहा है, सिंपल एक्सेलरेशन. मूव भी कर रहा है और फिर कुछ पार्ट स्लो मूव कर रहे हैं, कुछ पार्ट्स फास्ट मूव कर रहे हैं, देन इन एडिशन टू द लीनियर एक्सेलरेशन वी आल्सो चूज द एंगुलर एक्सेलरेशन ऑफ द ऑब्जेक्ट व्हिच इज इक्वल टू अल्फा. ठीक है, दो पार्ट्स को हम लोग चूज करते हैं. एंड देन उसके बाद व्हाट डू, यू राइट डाउन द लीनियर मोशन फॉर दैट ऑब्जेक्ट. ये जो ऊपर वाला ऑब्जेक्ट है, यू राइट डाउन द लीनियर मोशन फॉर इट. देन यू राइट डाउन द रोटेशनल मोशन फॉर इट. जो ऑब्जेक्ट नीचे गिर रहा है उसका इक्वेशन लिखो और फिर इन इक्वेशंस को सॉल्व करो. Do let me know if you have a problem writing down these equations and solving them. I'll help you with it. I'm always here to help. See you.